Open-angle glaucoma affects more than 50 million people worldwide, and the numbers continue to grow. Many physicians prescribe single-agent or combination medical therapy to reduce intraocular pressure. But the medicine is costly, requires daily administration, and may cause ocular and systemic side effects. Consequently, patient compliance is a serious problem. Argon laser trabeculoplasty, or ALT, is an effective alternative, but its use has been limited by the coagulative damage and subsequent scarring of the trabecular meshwork. Clearly, a new approach designed to counter these shortcomings is needed. A new treatment option is now available. Selective laser trabeculoplasty, or S.L.T, is a safe and effective alternative for the treatment of open-angle glaucoma. S.L.T is performed with the Selecta glaucoma laser system. This procedure was first made available in the U.S. once the Luminous laser system was cleared by the U.S. Food and Drug Administration in March of 2001. This is a Q-switched ND-YAG laser, frequency doubled to give 532 nanometers light with a 3 nanosecond pulse duration, designed and built by Luminous Incorporated, the leader in medical and ophthalmic laser technology for more than 30 years. The Selecta 2 offers a portable S.L.T solution for the treatment of glaucoma. The Selecta Duet offers a new combined laser system with the option to treat glaucoma or secondary cataracts. S.L.T is based on selective photothermolysis, the process targeting a specific cell and confining thermal laser energy to that target. This minimizes collateral damage to surrounding tissue. S.L.T, using the Selecta, specifically targets melanin-containing cells in the trabecular meshwork to lower intraocular pressure. Since only pigmented cells are targeted, heat damage to surrounding structural tissue is minimized. For the process of photothermolysis to be effective, the targeted tissue must have a thermal relaxation time greater than the pulse duration of the laser emission. The thermal relaxation time is the time required to dissipate thermal energy induced by the laser process. Melanin has a thermal relaxation time of approximately 1 microsecond. With a pulse duration of 3 nanoseconds, the Selecta successfully facilitates this process. The pigmented target cells are heated, and the surrounding non-pigmented tissues escape damage. How does it work? Aqueous humor circulates from the posterior lens chamber through the pupil and into the anterior chamber. There it circulates peripherally toward the anterior chamber angle, where it exits through the trabecular meshwork and finally through the canal of Schlemm into the venous system. The trabecular meshwork is a sieve-like tissue that filters the aqueous humor. It contains a mixture of pigmented, melanin-containing, and non-pigmented cells lining the trabecular beams. The practitioner is treating the trabecular meshwork with the Selecta laser. Confluent laser pulses of 400 micron spot sizes are placed along the meshwork. Although the mechanism of action of S.L.T is not completely understood, heat absorption by the melanin-containing cells induces a cavitation effect surrounding the melanosomes, which is accompanied by thermoelastic expansion of the cells, resulting in intracellular damage. With selective photothermolysis, the damage is confined to the pigmented cells, leaving the non-pigmented cells and the extracellular structure members of the trabecular meshwork intact. The pigmented cells respond to thermal stimulation by producing cytokines such as interleukin 1A, interleukin 1B, and interferon alpha. These chemical messengers in turn recruit macrophages that remove cellular debris and extracellular melanin from the meshwork. They also stimulate the release of additional cytokines. These cytokines play several roles. They induce cell division, upregulate synthetic metalloproteinases, increase the porosity of the endothelial layers of the trabecular meshwork and Schlemm's canal, and stimulate resynthesis of the extracellular matrix. The ultimate effect is to improve outflow facility. thereby reducing intraocular pressure. Although S.L.T is a new means of treating glaucoma, lasers have been used safely and effectively in the treatment of open-angle glaucoma for more than 2 decades. The glaucoma laser trial showed that argon laser trabeculoplasty provides good pressure control without systemic side effects. Nevertheless, A.L.T has been underutilized, at least in part because its effectiveness declines over time, and scarring of the trabecular meshwork often prevents retreatment. S.L.T advances the therapy available from lasers by offering the benefits of A.L.T without its limitations. S.L.T successfully reduces intraocular pressure, but does not cause the structural damage to the adjacent trabecular architecture like A.L.T. S.L.T has been proven safe and effective in clinical trials performed around the world with more than 2,000 patients, followed for more than 4 years. In a U.S. clinical study, 120 patients were enrolled who had uncontrolled open-angle glaucoma, who were on maximum medical therapy or who had prior A.L.T, and who also had poorly controlled intraocular pressure. From the graph, you can see that even for this advanced glaucoma group, that S.L.T dramatically reduced intraocular pressure within a single day, and this reduction was maintained throughout the follow-up period. At 26 weeks, analysis of the 101 patients completing the study revealed an average IOP reduction of 5.2 millimeters mercury in patients with maximally tolerated medication and an average of 3.8 millimeters mercury IOP reduction on previously failed A.L.T patients. 71 of these 101 patients responded with an IOP reduction of 3 millimeters mercury or greater. Even the efficacy of S.L.T in patients who had previously failed A.L.T is notable. With almost twice the response rate, over half of S.L.T treated patients in the previously failed A.L.T group responded, compared to less than a third of the A.L.T treated patients who respond after a failed A.L.T. Proper patient selection helps ensure the success of S.L.T. With S.L.T, patients with open-angle glaucoma now have another consideration for their therapy. S.L.T is being studied for use as first-line treatment for open-angle glaucoma. Also, investigations are being done to understand how much S.L.T may alter need for medications. S.L.T treatments have also been performed on patients with pigmentary, pseudoexfoliation, juvenile and angle recession glaucomas, who are poorly compliant to medical therapy, who are intolerant or unresponsive to medical therapy, who have had failed A.L.T, either 180 degrees or 360 degree. S.L.T, with the Selecta glaucoma laser system, provides a world of advantages. It is safe. S.L.T is not associated with systemic side effects or the compliance and cost issues of medications. Selective. S.L.T utilizes selective photothermolysis to target specific pigmented cells, leaving the trabecular meshwork intact. Smart. S.L.T stimulates the body's natural mechanisms to enhance aqueous outflow. Truly, S.L.T represents a whole new approach to managing patients with open-angle glaucoma.
To find out more about the Selecta glaucoma laser system, call us at 408-764-3000 or visit our website at www.ophthalmic.luminous.com.